Awesome. Thank you so much, Lee. So welcome, everyone. I'm Mary Cameron, and I'm very happy to help host today's webinar. I'm here because I'm just like many of you guys listening. I'm an AWK hygiene nerd wanting to learn more about the assessment and control of metalworking fluid health risks. And let's face it, it doesn't get much nerdier than that, does it? And I mean that in the most flattering way, of course, because metalworking fluid risk management is serious stuff. So thank goodness for the likes of you guys listening who want to learn more about this and go out there and protect workers' health. This is really important. And thank goodness for the likes of BOHS's Metalworking Fluids Expert Group, who wrote this wonderful new guidance document for AWK hygienists on metalworking fluid risks, which was written on behalf of the BOHS Faculty of Occupational Hygiene. So I am going to name all the expert group because they absolutely deserve this recognition. So the document was developed by Adrian Hurst, Stephen Larson, Samantha Lord, Carol Stern, Gareth Evans, as well as the lovely Rachel Powis, who is presenting for us today. So very, very big credit to them for developing this document. So Gareth was meant to be speaking today as well, but unfortunately he can't be here. He does send his apologies. But we do have Miss Powis, who is a force of nature, and you count for at least two people, I think, so we're good here. Rachel is the AWK Hygiene Technical Manager at EnviroChem Analytical Laboratories, holds Cert OH, is very well experienced in the world of AWK Hygiene consultancy, decorated scholar with a Master's of Science and certificate in ergonomics and human factors. I hope I said all that right. So I'm going to hand over to you from here. Please, everyone, drop your questions in the chat box as we go along. I'm going to keep track of them, and we'll hold a Q&A at the end. So over to you, Rachel.
Brilliant. Thanks ever so much for that lovely introduction, Mary. I am just going to try and share these slides. Is that working for you guys?
Nothing yet. Oh, it's
no,
just
okay.
oh, there we go.
I think it might be on a bit of a go slow. Sorry,
yeah,
mate.
if you just full screen that.
There you go. How's that looking for you?
Excellent. I can see that the lapping waves
perfect.
there, so you're good to go.
No, that's great. Okay, so as Mary briefly gave you an introduction, the main reasons for the BOHS developing this guide is because the risks for skin disease and lung disease in machinists exposed to metalworking fluids are well established. This is generally due to contamination of water mixed metalworking fluids. This can be metal contamination, chemical
Real quick,
contamination.
Rachel, I'm so sorry. I think we're seeing the wrong screen. I think we're seeing your desktop.
Oh, right. Okay.
It might be another window to click on.
Bear with me.
Oh, there we go. Full screen.
Oh, right. Is that working?
And then if you click the full screen, and then hopefully. Oh, you know what? It still goes to the other one. How strange.
How very strange.
I wonder if can it be dragged over or something?
No, that's what I'm trying to do.
Ooh, Lee, help.
Lee, help.
Yeah, so when you're on there, it which one would it be? So if you go to slideshow on the top.
Yeah.
The top bar. And then should be and then monitors on the right hand side, automatic, and then maybe select if you're using a multi-monitor setup there.
Right, okay, let me.
And then try going from beginning or from
try that
side.
now. Is that looking any better? Yeah, okay, perfect. I'll skip back to the beginning. Sorry about that. This is a problem with having to come into the office because my Wi-Fi at home's not working. So there's been a few last minute changes to the schedule. Right, so yes, picking back up from where we were, a lot of the reasons for the health effects that we're seeing are due to contamination of predominantly water mixed metalworking fluids. So this could be metal contamination, chemical contamination, or biological hazards, all of which increase the risk to health that we can see. So exposure is predominantly through inhalation, and this can be through breathing in the mist, fumes and vapours from machining, and all of these increase the respiratory health risks. One thing that has been identified is that many UK companies don't understand these health risks, and they're not doing enough to act to reduce the exposures to metalworking fluids. As such, there's been a lot of activities recently to promote good practices around control and reducing these exposures to metalworking fluids within the workplace environment. So BOHS has already organised several regional meetings, and there's been conference sessions all aimed at occupational hygienists and focusing on these control measures to reduce their health risk. Concurrently, HSE has worked with BOHS to develop good practice guides for occupational hygienists, but also information directly for duty holders for working safely with metalworking fluids. This is something that's been reflected by the UKLA stewardship group. In tandem with HSE, they've developed a good practice guide on managing the quality of metalworking fluids, and that was reviewed by BOHS members. There's also a lot of published guidance on YouTube, which training videos predominantly aimed at duty holders. However, there was a gap for guidance for hygienists on how to assess these risks. All this other guidance is available online. I'll leave this slide up for a few seconds so you can get an idea of where you can find these. But as I say, there was an identified need for specific advice for occupational hygienists to visit machine workshops and undertake these surveys for exposure to metalworking fluid. As Mary's already introduced, BOHS developed this guide through a metalworking fluid expert group. It's already been introduced to you, thank you. The panel included occupational hygienists and occupational health risk specialists. The guidance in its form now is available online, and it's been reviewed by HSE and both BOHS internal experts and external experts. So the scope of the guidance is to focus on risk to health from metalworking fluid and how to manage that. The sections on managing the quality of metalworking fluid, as well as assessing employee exposure to metalworking fluid and general good controls to reduce the exposure. One of the main takeaways from this guidance is an audit tool aimed at hygienists to be able to use in the field to assess the adequacy of controls. And we're going to talk about that a little bit later on towards the end of the presentation using a specific case study so you can see how it can be put into action. So the key elements of the guide, just illustrated in this figure here, focus on the maintenance and use of control measures. However, to provide a little bit of context for people who are using this guidance and using the audit tool, just need to talk about some other sections that summarise the hazards associated with metalworking fluid and some key principles for managing metalworking fluid quality. So the main health risks from exposure to metalworking fluid are respiratory disease and skin disease. So these conditions are caused by contact and exposure, mainly due to inhalation. This can be from the metalworking fluid mist, fumes and vapours, or respectively. The most serious respiratory diseases are allergic, and they include occupational asthma and occupational hypersensitivity pneumonitis. This is especially evident in older water miscible metalworking fluids, where as fluids age, they can become contaminated. So this can become contaminated with fungal or bacterial allergens or chemicals, and it's especially evident in poorly managed metalworking fluids. That's not to say that new and clean fluids are not a cause of respiratory disease. It's just that the risk greatly increases, particularly in older fluids which have become contaminated. No single hazard has been identified as a cause for these respiratory allergies, but it's likely that it's due to the bacterial and fungi or yeast growth in the fluids. As well as this, contact exposure can commonly cause skin disease. This can be irritant or allergic from contact with things in the fluid, but it could also be from wet work, especially where operatives are soaking their hands in fluid for quite a long time. Again, some individuals are susceptible to this because of the sensitizing metal and chemical elements within the fluids. So this is all to say that exposure to the hazards in metalworking fluids is a complex circumstance. Hazards vary, and that means that we're looking at a changeable exposure circumstance. Tramp oils, metals, biocides and microorganisms can accumulate in the metalworking fluid, which greatly increases or changes the health risk as the process goes on. There's also other considerations to take into account, and that's the way that fluids and droplets and aerosols are getting into the environment. So this can be from high-speed machining or cleaning down, which generates quite a lot of aerosol, but it can also be from volatiles or VOC emissions associated with the fluids and the oil. So with this in mind, and given the exposure and health risk, it's essential that employees exposed to metalworking fluids are within an occupational health surveillance programme. So early detection of these are important. Typically, health surveillance is undertaken once a year, and it may include lung function measurements or dermal checks for people with relevant symptoms. This guide is not to go over occupational health surveillance, but it does point to general areas and guidance and the sort of health surveillance that's important and should be in place. So if you need any additional guidance to this, I'd signpost you to the COSH Essentials, which focuses on occupational asthma and health surveillance for occupational dermatitis. What the guidance is aiming to do, however, is provide a framework for managing health risk and exposure. To give a bit of context on how this is discussed within the guidance, I'm just going to work you through some control measures, just following the hierarchy of control. So first off, there's been a lot of developments in the lubrication and cooling methods, which means that there are other options rather than normal fluids that are making their way into workshops and into the environment now. So one of the options for reducing exposure is to replace normal water-based metalworking fluids with an alternative. So within the last decade, there's been quite a lot of advancements in this, and this has been predominantly pushed through really for environmental sustainability reasons. But some of these new technologies could have the addition of being able to improve employee safety. So, for example, semi-synthetic and synthetic metalworking fluids, in which the mineral oil content's been rapidly reduced, could be a safer option because there is some evidence to suggest that bacteria can't readily grow in these environments. Additionally, plant-based oils are becoming quite popular, and they could offer some potential benefits from a workplace exposure point of view, mainly due to the fact that these aren't volatilized quite so easily. So potentially there's less VOC emissions. Other examples include dry lubricants, such as graphite powder or cryogenic cooling. These, however, have the potential to introduce other health and safety risks into the environment. Another thing that's gaining popularity is minimum quantity lubrication, or nanoparticles for cooling. So minimum quantity lubrication uses a reduced volume of fluid, which is applied as a very, very fine aerosol. And although this vastly reduces the amount of fluid that's used and takes away problems with old fluid because it essentially becomes a consumable, it does mean that the way that the aerosol is being generated could potentially introduce additional health risks. So again, enclosures and instruction for this sort of cooling can be quite important. And as hygienists, I'm sure you've got some ideas yourselves as to issues that might be introduced by using nanoparticles for lubrication. So moving on from here, with that little bit of background, we're now going to take a look more in depth with the guidance and what it is focusing on. So the main takeaway from the guidance is the BOHS audit tool and how controls are being applied effectively to reduce employee exposure. So with that in mind, I just want to give a quick rundown of control options that are available. So the guidance outlines practical control options, again, consistent with the hierarchy of control. It's not intended as an LEV design guide. Information from that kind of perspectives already widely available. So there's information from both the HSC and ACJIH, amongst others, focusing on LEV effective design. The guidance does, however, talk about how these can be applied for control, and as an occupational hygienist, how we need to be aware of exposure scenarios that they're aiming to control or risks within the workplace. So due to the nature of machining and the wide range of machine types, everything that we've come across within a normal workshop, it's unlikely that engineering controls are going to be a one size fits all. That being said, it's generally practicable and affordable to fit LEV on most CNCs, particularly where they're already enclosed. The guidance does talk about specific considerations for open plan or large gantry machines, but in the main, extraction is essentially going to be the best option for minimising exposure whilst minimising impacts on production rates. So ideally, LEV units will discharge outside, but recirculating units are commonplace within the industry. This is typically because they're low cost, but also other considerations such as the need to move machines around on occasion is a reason why they're quite so popular. So this does create consideration for reviewing filtration efficiency when we're assessing the controls, as any mist remaining in the returned air can become an exposure source. In tandem, work practices and procedures to reduce both inhalation and skin exposure to metalworking fluids can be effectively applied alongside these engineering controls. So a common consideration is with the use of compressed air, which is often used to clean components or tooling heads and is generally preferred because of the quality of finish that it can give. However, the use of compressed air line does generate large amounts of metalworking fluid mist and droplets within the air. So in addition to the inhalation risk that this can obviously cause, it can contaminate clothing and the skin, and the force of compressed air can also drive contaminants into the skin, which exacerbates any skin disease risks from this. So there's several practical and commercially available alternatives to compressed air lines, and they're outlined within the guidance and just on this table on the screen. So the guidance pinpoints to these and discusses risk mitigation measures, as well as discussing overall control strategy and the need to consider decontamination, skincare and suitable maintenance and management records for an overall control of metalworking fluids. So with that in mind, it might be a requirement for certain tasks, and it's consideration when you're handling neat metalworking fluids, but also chemical additives. It can be a consideration for draining and cleaning machine sumps. Again, the guidance is not meant to be an exhaustive list of PPE, but it does signpost to information to make clear and suitable PPE selections. So, and as we've already discussed, managing metalworking fluid quality is important for maintaining the fluid, but also mitigating health risks. So changes in the composition of metalworking fluids can give rise to bacterial growth, but it can also affect the fluid misting. So without going into this in too much detail, what you can see on the screen is typical parameters that need to be considered in a good policy to maintain and manage metalworking fluid quality. The guidance signposts over to existing work that's been done by the UKLA, and you'll find a lot more information on this within their guidance. So now to kind of the nitty gritty, and I imagine this is the bit that most people are here for, and that's exposure limits and control guidance values. Because of the vastly complex and evolving exposure scenarios that we're looking at with metalworking fluids, it does pose a challenge for occupational hygienists when we're assessing the risk to health and the suitability of controls. The problem's twofold. Firstly, the complexity of the risk factors makes it very difficult to derive a health-based exposure limit. So previous HSE guidance values have been withdrawn when evidence emerged that they were no longer protective of health. These have not been replaced. So there's currently the only remaining regulatory benchmark in the UK at least is the requirement to reduce exposure to LARP. There's alternative OELs that do exist internationally. And although the adoption of these can be quite useful as in-house standards in order to be able to compare results from exposure monitoring, where the aim is health risk reduction, they may not be sufficient, as there's further evidence to suggest that ill health can occur at levels much lower than these, which were much lower than the previous UK HSE guidance values. In addition, the second part of the problem is that developing a reliable measurement of exposure to metalworking fluids is technically difficult. So the HSE MDHS 95.3 was at its introduction seen as a thought leader in the approach of generating reliable metalworking fluid measurements. However, changes in the makeup of fluid composition, particularly the removal of boron salts because of their own health concerns, is leading to limited application of this method. Other sampling methods exist, but they all have their own limitations as well, which can range from evaporative losses or underreporting of VOC components to over-reporting by not being selective and essentially just being a gravimetric method, taking into account any particulates within the workplace as well. Ooh, sorry, I skipped on a little bit too quickly there. So traditional sampling methods may have their place, but they don't offer an awful lot of information on the dynamic nature of emissions within the workshop. They also focus very narrowly on the metalworking fluid component and none of the other health risks that we've talked about. Therefore, the guide is now advocating for qualitative techniques, and most of these are probably things that are already familiar to you as occupational hygienists. So methods that can be used for risk assessment and to assess the performance and suitability of control measures are things like a dust lamp or a Tyndall beam, smoke testing, and direct reading aerosol monitors. These are all useful tools, especially Tyndall Beam in visualising mist. The correct use of this method is already described in MDHS 82.2, and it can be useful when assessing routes of exposure or identifying any leaks within enclosures or any areas where operatives may be coming into a contact with an emission source. Smoke testing is very useful as part of LEV reviews, checking for leaks and ensuring performance of LEV, and also checking that enclosures are maintaining negative pressure. And lastly, DRAMs are a useful tool, providing the users aware of its limitations. So, for example, the accuracy of DRAMs can be greatly reduced in environments with high humidity, but also environments with high background particulate levels, which is something that you may come across in open plan workshops. Also, the way that they're calibrated is generally against solid particulates rather than aerosols, which is obviously what we're interested in when we're assessing metalworking fluids. So this means that we're looking at DRAMs as a qualitative tool rather than generating quantitative numbers to compare to any occupational exposure limits. So DRAMs are very useful though in determining relative changes in background aerosol concentrations, and we'll talk a little bit more about how to apply that when we get to the case study. So the guidance is therefore intended to take the approach of focusing on control of health risks and assessment to ensure that metalworking fluids are being appropriately managed. Before using the guidance, some key questions to ask your client is, do they understand the health risks and do they understand what controls they have in place? And what are they doing to manage these risks? Just on the screen here is a flowchart which is reproduced from the guidance, which talks through steps on that you might want to work through to make sure that the performance of controls is being looked at in a logical manner. So the last stage of this assessment is regular audits, and these can be carried out to ensure exposures are being adequately controlled. And the guide suggests a framework for an audit tool which can be used to check these control measures. So control of exposure to metalworking fluids requires the management of a wide range of controls, and it's not possible to verify the effective management of these using only exposure monitoring. So the tool therefore aims to provide a framework for assessing the risk to exposure through inhalation and through skin contact, and to give you information to be able to inform a suitable and sufficient risk assessment. So it considers the routes of exposure, it considers the exposure sources, and it considers process risk factors such as machining speeds, machine run times, frequency of interaction, as well as additional controls which are aimed for the fluid management and enclosures, LEV, and effective checks. So in this case study, I'm just going to walk through how the guidance was applied to a busy medium enterprise CNC shop. And the area had multiple conventional CNCs with varying degrees of control. Some were automated, the majority were enclosed, and the majority were fitted with LEV extraction. These were the recirculating type, but the LEV systems were fitted with filter monitoring to alert of any issues or anything breaking through back into the workplace. In this specific example, due to the size and complexity of parts that were being manufactured, parts cleaning was frequent and it was done exclusively by airlines. And on occasion, there was a need to undertake this outside of the machine enclosure, generally due to awkward areas that needed to be cleaned out or the size of the part. The site had been encountering recent ill health reports from employees, which was predominantly dermal symptoms. They had a comprehensive health surveillance programme in place, but this has up until now focused more or less exclusively on respiratory illness. The site had also done quite a lot of work on training to understand the health risks from airborne exposure to metalworking fluids, but there were some knowledge gaps, both in management and within the workforce, on understanding the risks from skin contact. So the initial assessment took place using qualitative measures, using a DRAM to track relative changes in aerosol levels and identify sources of exposure. So in order to establish a baseline for comparison of the DRAM results, measurements were taken in a background location, which is just identified as the baseline on the screen. And this was outside of the working area and taken before any machines were operating in the morning. So it's worth mentioning that there are considerable variables that can affect the results from the DRAMs. So this can include open doorways, letting in vehicle emissions, aerosol and particulate from neighbouring processes, which, as we said, is a consideration within our open plan workshops, and also general changes through the day, which may not all be increases of aerosol levels from metalworking fluids mist. So regular checks of background and baselines were undertaken to ensure that there was some comparability within the results. So the chart displays the raw data, and that's just in straight out particulate counts. And there were notably pronounced measurements taken during machine unloading. At this point, there had been no clearance times established, but also during airlines part cleaning, where you can see from the results on the screen, the droplets that were being recorded by the DRAMs and aerosol levels were much higher than what we can see in the baseline. Although not so pronounced, but still noteworthy, there was a relative change in aerosol levels at a gap within the enclosure of one of the automated machines. And this result was visualised using Tyndall beam as well to confirm that there was a mist leak. Having this real-time data helped identify that this was an issue that had come about from a part not being returned after a startup maintenance in the morning, which could be immediately rectified. So applying the checklist from the audit tool, there were several positive applications of controls and good practice, such as the machine LEV provisions, LEV monitoring on the recirculating systems, and training relating to inhalation exposure and health effects. However, there were some process risks and production factors which resulted in high risk practices, such as using compressed airline at high pressures outside an enclosure without an additional source of extraction or mist control. Furthermore, there was poor understanding of health risks for skin exposure, which was leading to uncontrolled dermal contact. Additionally, there were issues with the fluid management. So moving on to the second part of the audit tool, again, you can see there were some good practices in place regarding regular checks on concentration and pH and carrying out dip slides. However, out of scope dip slide results were not being actioned, which had led to bacterial contamination becoming prolific. Part of the reason for this was that checks were being undertaken as an administrative task and it hadn't been involving operatives in undertaking these. So using the audit tool allowed for identifying gaps within the existing control structure and allowed for actionable steps to be put into place to improve both the fluid management and controls specific to the identified high sources of exposure. So I hope that gives you a bit of an overview as to how the audit tool can be applied. Before I pass you back over to Mary, I just want to say don't forget that there's a wide range of guidance that is available. You can find this on the HSE website, UKLA website, and the BOHS website. And if you scan this QR code, that will take you to a link directly to the now published guidance. So
Awesome.
thank you very much.
Thank you so much, Rachel. So you're already getting applause buttons here. I'm going to give you one too. Yeah, it was a very, very good summary. I'm so looking forward to reading the whole document later. So it was excellent. We do have a couple of questions in the chat box, but you know what? I'm going to be selfish once again and ask my question first, and I'll get to your guys's. So
yeah, fire away.
Oh, awesome! Yeah, we have plenty of time, so we can really ram you with questions now. So one is a burning question I have. I think it's on a lot of consultants' mind. So if consultants as myself are listening right now, you'll probably be fielding the same sort of phone calls that I know I've been getting. So the client calls you up and they really want you to come to site and do sampling, right? Come sample my mist, right? And then it begins this back and forth, and they send you safety data sheets and all this. And of course, there's no boron, so 95 is out the window. And on occasion, it's viscous enough for 84. That might work. You might even not have to, but maybe consider IR spec or GCMS. It depends on what exactly the oil is. So you're kind of fishing around. And of course, also the while you're having this debate with the client, why a sample? To compare to what? To prove what? That can't be proved with qualitative means. But I find this conversation really goes back and forth with client quite a bit. So my question, anyway, that was big, big lead up. But my question to you is, what can we, the consultants, be saying to the client to help them understand that sampling isn't going to be necessary in the vast majority of cases, and that there's as you explained, debate on the utility of sampling results. And we also need to give them this answer quite quickly, because we're only on the phone and doing these email exchanges for so long until maybe they sort of say, oh, forget them, they're not going to give me my samples, I'll move on to the next consultancy. And maybe the next consultancy will be a little looser on these things for, I don't know, it's money, it's a job win. I know that's a terrible thing to say, but this is the real world, and we're competing against each other. And the next consultancy may say yes when I say no. Do you know what I mean? Like, let's face it, these things really do happen. So what's your advice? What can I say quickly to try to convince the client to go down qualitative first?
Yeah, so I think the main takeaway from this is that the guidance is not saying that there's no value in measurement, but there's a limitation with how traditional measurements can be applied. And if the client's goal is focusing on control, are their controls working, and health risk mitigation, then they're going to get a better answer by using these holistic tools which are already available. Additionally, these sort of things are a lot more accessible than traditional sampling methods, which could be quite expensive if we're going down the route of multiple sampling multiple times. And because of the dynamic and changing nature of the health risk and exposure like scenarios, regular auditing is likely to give a better result where the end goal is health risk mitigations.
Mm-hmm. Awesome. I like the financial argument there. That's probably going to be a big one to win them over this. So excellent. Thank you. You know what? We just got flooded with questions, so I'm going to stop prioritizing mine. Right. So one question came in. When using the DRAM in the case study, can you relate the peaks found to a concentration?
The short answer to that is no. The DRAM results were a overall particulate count, and because of the way that the DRAM is calibrated using solid particles rather than aerosols that we're looking at, it isn't giving a result that can be directly comparable to an airborne concentration. So it's important to understand that the results from the DRAMs are only going to give you relative changes, and it should be taken as a qualitative rather than a quantitative measurement.
Mm. Excellent. Awesome. That actually prompts a side question. And I just saw Sam Lord pop up, and it's a question for you, Sam. So I hope you don't mind if I just tangent onto that because it's related to what you've just said. And HSC's RR1149, which was a 2019 research report, it says about it's a report about monitoring metal fluid mist using the particulate counters, the DRAMs. So it concludes with the need for research in machine workshops to address knowledge gaps on the performance of DRAMs for monitoring the mist alongside lamps and smoke to visualize the containment and clearance. So my question was, is there any further update to this 2019 research? Has that research continued? Is it planned? Any updates for us on top of that?
Yeah, so Science Division of HSC Science and Research Centre, they are doing a lot of research generally in the arena of real-time instruments and particularly low-cost sensors, which is quite fast-moving technology. And I know there is some work that's going on, although it's not metalworking fluid specific, but that's happening. That has been happening, and that will be reporting probably within the next year. But the other thing that is happening is a lot of the work, what HSE does these days is engage with external stakeholder associations. So Rachel mentioned the United Kingdom Lubricants Association, and that is Gareth actually does a lot of work with them now as a consultant. And I know because we were talking about it this morning, they are going to be looking at sort of characterising the air in and around a machine shop, including metalworking fluids, and that work's going to be hopefully undertaken. It's still at the proposal stage by some master's students, but in a workplace. So again, we'll have a little bit of involvement. It won't be HSE research, but we certainly will be sort of interested in providing a bit of technical input with our experts with real-time monitors. So that's where that is. But I would say, just as a general comment on DRAMs, hopefully call them DRAMs. I think I don't know where that's come from, but real-time monitors, aerosol monitors. There's quite a bit in the guidance, and there's also a reference to a document which I'll put in the chat. But it's really to sort of make people aware, particularly as a hygienist, of the sort of the limitations of using a DRAM, and it's really important, I think, and this is what this guidance hopefully would do to try and sort of navigate that and particularly advise your clients on how to use it and how to use it yourself. And I think going back to another question that people were saying about how you use DRAMs, I think it's really and certainly this is for all direct reading instruments, really, it's sort of they're really useful because you sort of become familiar with the environment that you're measuring. So rather than just sort of looking at it and looking at the value and taking that value and interpreting it, it's more looking at the relative changes in and around the machine, but relative to the workshop air as well, because other particle generating processes may be happening. So, but hopefully this guidance will start to sort of, I don't want to say it demystify because I put a terrible pun in there, but yeah. So that's hopefully a long-winded answer to that question.
No, excellent. Thank you. We'll keep our eyes peeled for that research, and hopefully it's shared far and wide. Awesome. Next question. So can you comment on assessing and controlling the Legionella risks from metalworking fluids? Was that covered in any way in the guidance document?
No, we don't cover, I don't think it is covered in there, but it's a good question. I know HC's got a web page that does sort of state what people should do. Again, I'll pop the link in the chat shortly. But I think one thing, I suppose a metalworking fluid is identified as a potential Legionella risk system. It does for fluid control and bacterial control generally, you will have a level of biocide added to that coolant. And certainly we've never had any cases of Legionnaire's disease associated with machine operators. It doesn't but that doesn't necessarily mean, because the sort of the microbial environment can be very variable. But it's not to say that there's never any Legionella in fluid, but there's probably the the more specific risk assessment could include the acknowledgement of Legionella, but it doesn't need any additional measures. But perhaps the other thing to maybe mention is also, if you're ever going to be using like the water source that you use to make up your coolant, make sure that obviously that's from a mains fed. And I don't think people would use any sort of well, they might have an IBC full of water potentially, but just sort of some basic precautions. And the other thing interestingly actually about metalworking coolant sumps is the temperature as well, because that's going to affect all of the microbial population. So by taking the dip slide measurement, although that won't tell you about Legionella, it will give you a general indication of microbial sort of population and fluid quality in terms of the microbiology. So, but I'll put the link in. But yeah.
Excellent. Thank you so much. Awesome. A question came up for if Rachel, you could put the QR code back on the screen. I saw Lee you put it in the chat, but I'm just thinking the people watching on YouTube actually will probably want to scan it.
Yeah,
so it'd
sure.
be great if it could be back up just to get more scans.
Yeah,
whilst you're doing that, though, I have another HSC question. Sorry, Sam, you're getting
Sorry,
loud.
Sam.
That's okay.
If HSC could comment on the minimum requirements for LEV control that return air to the workplace.
Yeah, that's a good question. I've been asked that by a few people. Again, this is what this guidance is all about. Really, there's no, and it relates to another question which I've seen about the level of filtration that's required. Ultimately, we want to make sure that no fine mist comes out of the LEV. So determining that using the methods that are described in this guidance, they're very much sort of qualitative. So you're using a dust lamp to see if there's any fine mist coming out of the, not just the filter, but the casing of the LEV system itself. And also the dram, again, like what I was saying earlier. And I do know that I think Carol Stern's spoken at a few other BOHS events, but I know Carol uses a direct reading instrument, and she uses it to assess whether any particulates coming out of the filters. But again, it's just a relative indication of whether or not you're getting any sort of mist or fine particles coming out of that. Mm-hmm. So there is no answer in terms of a number. But it is something which I know we're doing. Just generally, HSE is going to be doing some work to look at recirculating systems for things like silica and wood dust, and metalworking fluids is hopefully also going to be sort of included in that. But that's going to be sort of research that's happening sort of going forward into the future. So again, sort of just maybe watch this space for that. Mm-hmm. But if anyone does want to sort of find out a bit more, please, I know Carol was part of the expert group here, and I'm sure she won't mind being contacted. I'll say that now. God, I've said that on YouTube now, but I'm sure she won't mind being contacted just to have a chat about how she does her work.
Excellent. Thank you. That actually attaches to the next question, which was to clarify what was meant by a high efficiency filter. Does that mean H13, H14 HEPA filters? But I think the answer is that will be in the research for next year where this will be investigated. Yeah. Okay, right. Let me have a scroll for anything more. Lots of just praise and all sorts like that. You know what? I did actually have one more HSC question, if you guys don't mind me. And Sam, you still have the
yeah, that's fine.
Enthusiasm for it. So it was to do with another research report. It was RR1171, and that talks about the compressed air guns. And it discusses how machinists, it said they regarded air guns as still the most efficient to clean the components, and so they quite favored it. And the new air gun designs that reduce aerosol and droplets, they were more expensive. And that research report concluded with more evidence is needed about alternative cleaning methods. So I was wondering, what's the update there, as well as more research planned? Or?
Yeah, there's again. I mean, it's actually quite interesting. We had this workshop where we got people involved in the industry, including users, and And I was actually I was on site doing an inspection, and I was just chatting to this the company, and they had this vacuum gun that they used to clear swarf. And it turned out, and then I sort of got talking to them. They'd done this massive sort of spreadsheet of different methods of fluid swarf removal or fluid cleaning, and that actually informed that workshop. But it was very much the use of alternatives to compressed air was certainly back then very much at its sort of early stages, and I think it probably still is. So we're very much sort of looking at feedback from anyone, and including anyone on this call actually, where alternatives such as vacuum suction guns, or you can get cooling fans inside the CNC machines. But I think there's going to be different degrees of effectiveness depending on the machining process and the level of cleaning required. So yeah, it's still it's something which, you know, we were the research sort of set the ball rolling, as it were, but we're not doing anything actively on that, other than we have as part of that, and there was a research study done by one of the scientists up at Science Division to look at behaviour of use of compressed air guns. And it's a little bit like ourselves using jet washers. You want to turn it up as high as you can because it's quicker to clean everything. The same thing happens with compressed air. So a lot of it's to do with behaviour and why people want to ramp up everything as high as they can, because the perception is that it'll make them do something quicker. But actually, they turned it down a little bit, then it can still be effective at cleaning the component, which is really important for machining metals. But it won't create as much mist. So there's a little bit of work and sort of understanding to do that. And we did write some articles in, I think, Compressed Air Matters. Those of you, a publication that probably you wouldn't want to read, but to try and get that audience. And interesting, actually, again, this morning we were chatting, because I had the HSE Technical Working Group meeting. We were sort of, talking about the need to train both apprentices about health risks of metalworking fluid, but also make sure that when they get into companies that they don't just get, told that was your apprentice training, we do things differently here. It's about trying to keep that momentum and changing any behaviour and making sure they're much more aware of the health risks of metalworking fluid, including compressed air use.
Definitely awareness. Yeah, no, excellent. Awareness is key, isn't it? So, no, great. Thank you so much. I haven't seen any more questions in the chat box. So, you guys, I'm going to continue to be selfish here and ask my own questions if nobody has any of their own. So, I've just read the draft version of the document as the finals just come out. But when I was reading the draft version, one question I had was, it's very much about mist, and that's obviously a very important route of exposure here that needs controlling. The dermal risks as well, which of course was covered too. But I was just wondering if there's any more guidance you guys could give us about when it might be warranted to investigate the dermal risk, like with measurement, or what sort of qualitative investigation would we do? Or if we did need to measure, what's the best sort of method? I know there's inception, removal, in situ visualization. There's all sorts of things to choose from. Have you guys is there a case study, or is there anything that came up in your discussion in the expert group to help us determine the dermal risk as well?
Sure. I think with that, Mary, I kind of refer you back to what we were saying earlier about the inhalation risk. Is why would we want to be taking a definitive measurement? What's the value in deriving a definitive measurement, and what are we going to be comparing it against? And because both inhalation and dermal contact is a vastly complicated exposure scenario, these qualitative reviews, audit reviews, and a look at what controls are in place are probably going to be giving you a better understanding of if the risk is being adequately managed or controlled, rather than generating numbers for maybe the sake of numbers. I mean, people love numbers, but people also quite like visual result as well. So some of the work that the HSE have done for kind of training and encouraging education is those UV tracer images, which have been very effective in communicating what these risks are to the end users. I think a conversation around that might be more valuable than going down the route of trying to establish how much is coming into contact with people's skin and when.
Mm-hmm. Oh, thank you so much. Yeah, very well put. I think we can all agree that'd be quite rare that mist or normal exposure measurements would actually be needed. So we just go out there and keep pushing qualitative assessments and control over everything else. That sounds like the key here, doesn't it? Well, thank you so much. I mean, we're almost out of time. No more questions have popped up, so I'm just going to say thank you.
Can I just?
Oh, you go
sorry,
for
yeah,
it.
just
Yeah,
a little
go ahead.
plug. So I should have said this before, but the other thing which HC are trying to are doing as well actually is and it sort of supplements this guidance in a way, but we're developing, we've actually recorded them, some short videos which will sort of show talk about LEV and also show the use of a DRAM and dust lamp in the environment of a CNC machine. And it's really to sort of plug that gap with the, I think you mentioned the UKLA fluid quality videos, which the UKLA and HSE put together. But these ones are done by HSE and they're in the sort of final stages of editing. They were recorded in September. So it's just really a watch this space, but that will hopefully again sort of try and sort of illustrate and those of you who are trying to sort of communicate with your clients as well, illustrate what we've been talking about in the guidance and we're trying to sort of to talk about. So just a little plug for those as well. But yeah, watch this space and I'll make sure that BOHS get sort of the links and that we can sort of advertise that through the BOHS. So yeah, thank you.
Yes.
And also
Please.
Carol's on the line, so and she says she's okay to have her, she's put her email address in the chat, those of you who want to talk to her about that. And also someone else has just plugged the BOHS Scotland mini conference, which Carol and my colleague Russell are going to be talking about metalworking fluids. So, so yeah, sorry, I've done all your plugging for you.
No, that's great. That's on the 28th of November, that Scotland meeting. So anybody who's up north there, do go on the BHS website. Well, thank you so much. That was great Q&A. Thank you everybody for attending and just wanting to learn more and go out there and protect people's health, right? That's why we're here. So just to end with a really big thank you to Rachel. Thank you so much, Sam, for jumping in with the Q&A. That was great. Really good learning. Please, everybody, go away, read this metalworking fluid guidance document in full. It's excellent. It's not on the BHS website. And you will see here, it says, get in touch, right? On the metalworking fluid guidance document, it says, we welcome feedback. When you open it, it says, please get in touch. We welcome feedback. And it's membership@bohs.org. If you're reading through and you have questions or comments, send it to that address and they will welcome that. So thank you again. Please do rewatch or share this recording. It's available on YouTube soon. And I think we've now just demystified metalworking fluid, haven't we? I stole your pun there, Sam. I had to do it. So thanks everybody again and see you next time.